So let's take a look at real-time water loss control. Taking here some district metered area or DMA information for the water industry, a flow can be monitored using a web visualization tool like PyCoreSite. Thanks to a partnership with Esri, this data can now be visualized in the context of its location, like here using Operations Dashboard for Esri ArcGIS. The Bedford Low DMA can be analyzed more closely. Its current flow and our total and last day total in cubic meters are examples of operational data that can be checked. Historical values for the flow can be easily analyzed using integrated PyCoreSite functionality. Further analysis can be achieved on the discharge pressure of pressure-reducing valves or PRVs of the DMA zones by selecting the ones close to a point of interest. Advanced pressure analyses are now intuitive as we clearly see how close the assets are and in what zone they're located in. Average pressure for the 4 PRVs can be here seen on the left against maximum and threshold values. Past leakage events can be reviewed by navigating to a time range of interest for the flow. Here, the flow increased abruptly by about 75 cubic meters per hour in a cast iron pipe. This is typical of a main failure on a medium-sized pipe. This information and standard techniques allow to pinpoint a leak location. Part of this analysis can be performed by exposing the historical data in an ad hoc PyCoreSite window like this one, where all 4 PRVs to that DMA zone can be trended next to each other to compare the reductions in their discharge pressure due to the increase in the flow. This is typical reviewing process, but to move towards real-time leakage detection, you can't be sitting in front of a dynamic map all day. Thanks to PyNotifications, rules can be analyzed in the background at all time and let you know when something of importance is happening. Here, a high deviation alert occurred for the Beaver Bank Intermediate DMA. The email received contains a link to an ArcGIS online map, shown here, fed with operational data from the Pi system. Thanks to the Pi integrator for Esri ArcGIS, the DMA zone in alert shows in red. There is indeed a zone in alert. Analysis confirms it is a true leak. Since moving assets can also be monitored on the map, dispatch crews are enabled and current location, status, and traffic information are used to dispatch the crew that will be able to fix the problem in the minimum amount of time. Faster notification is the first step to finding and reducing the runtime of the leak, as many leaks go undetected and do not surface. This was true for a leak that went undetected for a couple of days due to the fact that the water from the leak was indeed flowing freely and did not surface. It ended up being a service lateral to a vacant lot that had been turned on for an unknown reason. Thanks to the combination of space and time information, real-time leakage detection is possible. We are now able to identify an issue, which could be a leak, a bad meter, tampering, or others, within hours as opposed to days.